All right, hi. Welcome back, everybody. I know a lot of you in geometry are working on chords and angles within circles. We're kind of on the circles chapter. So, in number one here, this isn't really about chords. This is more about radii of circles, right? So, in this question, it's basically asking what can you conclude about WOX and ZMY, and it says given that the circles are congruent, so meaning they're the same size exactly. Well, if you were to make this and this into a triangle, well, what do we know? OW and OX are both radii of the circle. And because this is the same circle as well, ZM and MY are also radii. So obviously we did a ton of triangle stuff before this in previous chapters. So WOX, triangle WOX, and triangle ZMY are congruent by side angle side, the side angle side postulate. So I'll write that down here. So triangle WOX is congruent to triangle ZMY by side angle side. What can you conclude about this is basically what the question is asking is that WO and OX and ZM and MY are all the same length. So that being said, if it says the two circles are congruent, anytime you make a radius, they're always going to be the same length no matter what. If you go from the center to the side of the circle. All right, so let's look at this next one. This says find, let's see, which one did I choose here? Find the value of x, and let's put in some values here. So let's say this is 6.3. This is x, just this little part. And then let's say this whole thing is 10, okay? So this is the, I think the biggest theorem in this section. So if you have, this is, let me label everything here, right? So, you know, in a guitar, you have all the strings going across, right? That in an acoustic guitar, there's the opening, the sound hole. Well, everything going across is a chord. So think of it like this. This is a line going across from here to here. This is a chord of the circle. Same here, this is a chord. Now, because it's given that this is the same length, this line right here and this line right here are the same length, you know that the chords are the same length. So, you know what? I will write theorem 1, chords equidistant from center have the same length, meaning this is the same length, so so this right here is the same length as this right here, so these chords are the same length. And the second one of importance is that if it makes a right angle, if this line from the center makes a right angle, it cuts the chord into two equal parts. So chords at right angle from center are bisected, right? We use the word bisected because that just means that this line right here cuts this in half. So if we wanted to find x, well, if this is 6.3, then we know that this is 6.3. Then we know it's given that this whole thing is 10, and if it cuts it in half, that means that this part's 5 and this part's 5. Well, like I said, chords that are equidistant from the center have the same length, so that means this has to be 5 and x has to be 5. So I'll write the answer right here. X equals 5 in this example. Okay, and then one last example, a little bit trickier, but using kind of building on the first two problems we just did. So we know this is 1.9, all right? We know that, so this is really important. It has to be a right angle for this and this to be the same. If it's not a right angle, let me just do a little aside here. So if that went down and it's like a chord that's not at a right angle, it doesn't cut this in half into two equal pieces. But because this is a right angle, this is cut in half. Well, you know what? There's another piece of information in this problem. They say that this whole thing, the whole chord is 9. So that means that this is 4.5 and this is 4.5. Okay? Now, how do we find x? That is a very good question. Well, this is a radius of the circle, so we can take, going from the center to this point, I'm going to draw this in another color because this is a new line. Well, this is also x, because they're both radii. And what do we have? A right triangle. So 4.5 squared plus 1.9 squared equals x squared. 4.5 squared plus 1.9 squared equals x squared. And let's do a little calculator math here. 4.5 squared plus 1.9 squared. And then we'll take the square root of that. So 23.86 equals x squared. We'll square root both sides, and we get x is 4.9. 4.9. All right, so those are three examples using the theorems right here. Equidistant chords make the same length chords, and then if it's a right angle, it bisects the chords into two parts. All right, so I hope it helps, and I'll be back with more videos about circles soon.